All right, welcome to The Explainer. Today, we're not just crunching numbers, we're actually solving a mystery. We're going to follow the trail of a powerful algorithm that's designed to predict financial default. Yep, this is a real-life data detective story.
So, just think about this for a second. It's a pretty wild question with some huge implications, right? What if a bank, just by looking at your data, could know with some startling accuracy whether or not you'd pay back a loan?
And look, this isn't science fiction, it's not some movie plot. This is the real deal. It's data science. So we're going to follow the clues step by step, and you'll see exactly how the experts take just a messy pile of raw data and turn it into a powerful predictive tool.
Okay, so every good investigation starts with the evidence, right? The case file. And in our story, that file is a huge collection of financial histories. Let's crack it open. And the sheer scale here is just huge. We're not talking about a dozen or even 100 cases. We're looking at almost 150,000 different loan applications. And you got to remember, each one of those is its own little story, its own set of clues we need to figure out. So this is it. This is our evidence. You're looking at a snapshot of the raw data. And for every single one of those, what was it, nearly 150,000 applications? We have 34 different columns of information. We're talking everything from income to what kind of loan it was to their credit history. This is ground zero.
But hold on. Before we can even think about finding answers, we have to clean up the crime scene, so to speak. You see, raw data is, well, it's almost always a mess. So the very first job of any data detective is to sort the good clues from all the junk.
And bam! Right away, we hit our first major hurdle. Massive gaps in the evidence. I mean, just look at this. A quick check of the data shows that over 36,000 applications, they're missing the interest rate. I mean, how are you supposed to build a reliable model when you have holes that big? And I gotta tell you, this is such a meticulous process. It really is like a forensic expert dusting for fingerprints. The data scientist has to go in, find, and deal with every single little imperfection before the real fun, the analysis, can even begin. So, on top of the missing data, we've also got what you could call corrupted evidence. In the biz, they're called outliers. This chart here, this box plot, it shows us the spread of interest rates. Now, most of them are kind of clustered together in a reasonable range, but then you see those dots way up high, or that one down at zero. I mean, a 0% interest rate? No way, that's just impossible. And that kind of bad data can totally skew the results, so it's gotta go.
So what's really important to get here is that this whole cleaning process, it's super systematic. There's a clear game plan. Step 1, you find all the missing stuff. Step 2, you hunt down and get rid of those wacky outliers we just talked about. Step 3, you have to intelligently fill in the gaps, usually with statistical averages. And then finally, step 4, you double and triple check everything to make sure the data is spotless.
And after all that elbow grease, here's the result. Check it out. No more missing values. Our evidence is now clean, it's complete, and it's reliable. Now the real detective work can get started.
Okay, let's move on to the next phase, because this is where it starts to get really interesting. With our squeaky clean data, our detectives can start to build profiles. The big idea here is, instead of treating all 150,000 people the same, they start grouping similar applicants together. Why? Well, it helps them understand their behavior a whole lot better.
So you might be asking, how do they decide which clues are the most important for building these profiles? Well, they use this really cool technique called information value, or IV for short. You can just think of it like a scoring system for clues. It literally tells the data detective how powerful a piece of evidence, say income, is at predicting an outcome, like a default. If you get a high IV score, you know you found a really important clue.
And boom, here we see that exact idea in action. The analysis found that income had a really high information value score. Ding, ding, ding! That makes it a super powerful predictor. So using that key insight, the analyst sliced all those applicants into 4 distinct groups, all based on their income. This is what lets them do a much more specific, more tailored investigation.
And this is what that gives us, our 4 main borrower profiles. The data itself showed these natural groupings. The analysts just gave them labels. MI,
SE1 and SE2 for different kinds of small businesses, and then ME for the medium-sized ones. The critical thing to remember is that the model assumes each of these groups is going to behave a little differently when it comes to their finances.
Okay, now it's time to actually build the case. And here's the genius move. Instead of building one generic, one-size-fits-all model, they build a separate, custom-made predictive model for each one of those 4 profiles. The big question is, will this specialized approach actually give them more accurate predictions?
This chart here, it's called a confusion matrix, which sounds complicated, but it's basically the model's report card. This is the moment of truth. Let's just break it down real quick. See the box in the top left? The model correctly guessed that 5,460 people would not default. That's great, but now look at the box next to it. It got it wrong for 646 people, flagging them as risks when they were actually safe. So this little grid shows us exactly where the model gets it right and where it gets, well, confused.
So, when we zoom out and look at the final accuracy for all 4 of our custom-built models, the results are pretty darn good. We're seeing accuracy ranging from 77% all the way up to 82%. And let me tell you, when you're trying to predict something as complicated and messy as human financial behavior, that is seriously impressive.
And this really brings us to the main takeaway of the whole investigation. The secret weapon? It was splitting people into groups. It was the segmentation. By not treating everyone the same, and instead building these custom profiles, they created a way more accurate, way more powerful tool. It really proves that one size does not fit all.
And so our data detective story comes to a close. We started with messy data, we cleaned it, we profiled it, we built models, and what we're left with is the ultimate prize, a set of mathematical equations that can, in a way, peer into the financial future.
Now, I know this looks super intimidating, but don't worry. This equation right here, this is the final trophy from our entire investigation. It's basically the brain of the model for one of those groups. Every little piece of evidence, like income or property value, gets its own specific weight. You just plug in an applicant's details, and this formula spits out the probability that they'll default. All that work boiled down to a single powerful piece of math.
And that brings us to our final thought for today. We've just walked through how data science can build these incredibly powerful predictive tools. But think about it, even a model that's 82% accurate is still wrong 18% of the time. So as these algorithms get woven deeper and deeper into our lives, making huge decisions about our loans, our jobs, you name it, it raises a tough question. Who's responsible when the algorithm gets it wrong? That's the thought I want to leave you with. Thanks for joining us on The Explainer.